Good morning, everyone. Uh, Welcome to the first problem solving session for the course Geosynthetics and Reinforced Soil Structures. And my name is Pranjal Singh. I am a PhD scholar at IIT Delhi, fifth year PhD student in geotechnical and geoenvironmental engineering. And I will be the TA for this course, specifically for the problem solving session. And the template that we are going to follow in this session is that after every week of lectures, we are going to have a 2 hour session on Monday from 7 p.m. to 9 p.m. Uh, so we have around 12 weeks of lectures. So we are going to have 12 sessions, a minimum of 12 sessions. If we require more, we can have a few extra sessions also. And we are going to focus on solving problems related to the topics which have been discussed in the previous week. And it is encouraged that whatever doubts you have regarding the questions or from the lecture, you please ask. We'll have a discussion. And this will be a more practical related sessions than theory. And we also have a Google discussion group for the course. So you are also free to ask your questions that in that group. The other TAs and professor will try to answer your questions, and I will also be looking at those. So you have multiple forums to ask your questions. So it is always encouraged that whenever you have even the smallest of doubt in the lectures or in the problem solving sessions, you can do that. And so we'll just I'll also share my contact details by the end of the session. So you can reach me by email or by sending me a text on WhatsApp, or even if you feel like, you can also give a call. uh, and not only related to this course, but in any conceptual problem related to soil mechanics in general. So uh, we'll start with this week's problem solving session. So in the first 2 weeks, will the most of the content is descriptive. There are not a lot of numericals involved. Uh, so the questions will be relatively simple, but it will be very important to, because it is important to understand geosynthetics, the basics of geosynthetics in order to further solve problems related to that. So in today's session, we'll have some MCQ questions, which are very descriptive, and just try to solve that. I will give you some time to solve that, and at the end of the session, we'll discuss the solutions for those questions. And though this also is a recorded session, so the this video and the questions PDF and solutions PDF will be uploaded afterwards, so you can watch them at your own convenience. But it is encouraged that you please attend these sessions so that we can have a good discussion, and that obviously helps more than looking at the recorded lectures. So before starting with the actual questions, I'll just have discuss a uh, few cases of the use of uh, geosynthetics, particularly the reinforcement aspect, how it improves the performance, strength performance, and stiffness performance of soil structures. And I'll just give a glimpse, not, I won't go into the details, but just to give a glimpse of how the functioning, particularly to about reinforcement works. So I'll just start. I think Professor Rajagopal is also joined. So sir, if you want to say a few words, or I can start directly. Okay, so I think Professor Rajagopal is not there, so we'll directly start. Uh, so I'll first of all upload the questions. It will be uploaded on the chat, and I will also share my screen so that you have the questions visible. And then afterwards, I'll have upload the solutions also. So let me just first upload the questions. These are very basic questions. Uh, Let me just share the screen first. I hope you can see. So this is the first questionnaire. So we have a total of 13 questions, and these are very basic questions. If you have attended the first 3 lectures in the first week, most of you would be able to answer all of the questions. And obviously try to answer it without looking at the lecture material. But if you are not able to find the answer, then you are free to look at the lecture material. I hope all of you have downloaded the PDF of the all the 3 lectures. It is available on the NPTEL website. So just before attending the session, it is advised that you go through all the lecture PDF, so that you can brush up and you can ask your doubts in the session. So before starting these questions, I will just share some examples, a couple of examples, that's it, about the application of geosynthetics. So, so this is a typical example for the application of geosynthetics for the purpose of reinforcing the soil. You can see in front of you is a vertical wall. The green side is the original soil, or a soil which we have to support. So this structure can actually be used to support embankments for highways or for railways. So we know that, I assume that you have some background of soil mechanics. So we know that no unreinforced soil would not be able to uh, stand at this inclination of 90 degree, because there will be some uh, failure occurring and the factor of safety would be less than 1. But in case of space restrictions, if we have to uh, create a wall, so one of the approaches could be is to use one of the geosynthetics, which is known as geogrids, which actually provide reinforcement to the soil. So these horizontal lines, 4 horizontal lines that you see in this fill. So this is the engineered fill. So we place this engineered fill in different layers, one by one, in construction sequence, and we in between we lay the geogrid layer. So what this actually does is, if I run a slope stability analysis, so this is actually GeoStudio, which is a very famous uh, limit equilibrium analysis method for analyzing the slopes and calculating the uh, factor of safety. So if I run a slope stability analysis, you are going to see that we have a slip surface and we have factor of safety. So these are the different zones of factor of safety. So if you see that the factor of safety, most of the region lies between 1.44 to 1.52, and the factor of safety, minimum factor of safety for the critical slip surface, which is represented by this white line. You can see this white line. So this is the critical slip surface. So here the factor of safety 1.401. So which is greater than 1. So this slope will probably not fail. So what if you know that for a typical slope stability analysis, we divide the moving mass into different slices. So here you can see that we have these multiple slices. So if you look closely to the force of a particular size, say I look at uh, sorry, if I look at this slice, for instance. So these are the force diagrams. Now, if you closely look, there is a horizontal force of 9.28 kilonewtons acting on this slice. Rest all forces are the normal force and the shear force. This 21.171 in downward direction is the weight of the slice. But this horizontal force, which is the stabilizing force, this is helping to stabilize the slice, is coming from this reinforcement. So what is happening is when the soil mass, which is on the right hand side of the critical slip surface, is trying to move towards the right because it has failed. When it's trying to move towards the right, the the geogrid actually acts as a net to stop the right hand soil mass to move away. So it is actually gets in tension and it is actually trying to hold and stop the whole mass on the right hand side of the critical slip surface to move away. So because of the tension, a net left force towards left is applied on each of the uh, slices, and that's what you can see. And if you see that here it's written also that reinforcement load used is 9.2857. So because of this inclusion of that net force towards the left hand side, the factor of safety has been increased. So it is because of this, which is known as membrane effect. It is because of this membrane effect that we are able to improve the factor of safety. And you can see that there is some rectangular portion depicted on the geogrid, which actually represents that whenever the soil mass tries to move towards right and some tension is generated. So we need to ensure that there is sufficient embedment for the geogrid so that it can increase, so it can sustain that tension. Suppose the tension is too much and there is no sufficient embedment. Suppose the length of this geogrid would have been very short. So what would happen? That it would just slip out of the uh, soil, which is on the left hand side of the critical slip surface. It would just slip out. So we need to enforce that there is sufficient embedment. It's a similar concept of bonding that we provide in RCC structures, where we have to ensure that sufficient bonding stress is developed at the reinforcement whenever they are in tension. So it's a similar concept that we have to ensure that there is sufficient embedment. So there are two concepts involved. One is that the friction should be greater than the total tension force, and the tensile strength can also has to be greater than the tension force. So there can be two cases. Even if there is embedment is enough, but the tensile strength of the geogrid is not enough. The geogrid would break. So you have to ensure both the things. We'll study about this in detail. You don't have to worry even if you're not able to understand it. It is just for a brief introduction. And so this actually represents how much length of the geogrid actually embedment length is required. So since we have provided embedment length greater than this, so there won't be any issue. This actually geogrid will fail in tension rather than in embedment. So here we have taken, if you look at the properties of this uh, geogrid, we have taken a pull-out resistance of 75 kPa per unit force per unit area. So this value is actually constant. But if you see that whenever the geogrid is at the lower level, you know the normal load from the soil weight above is more. So the friction on the geogrid will be more. So you can see that the bottommost uh, yeah. So the bottommost uh, geogrid would provide more reinforcement than the uppermost geogrid. So that's why we have an option of pull-out resistance, which depends on the normal load. So it's based on the simple Mohr-Coulomb equation of C dash plus sigma dash tan delta dash. We will discuss this in detail. We don't have to discuss it right now, but just to show you what I mean is I have changed I have three cases. The first case, I have taken a constant pull-out resistance, and in the third case, it is dependent on the normal load which is acting. So now if you see, the factor of safety has actually reduced from 1.4 to 1.19. So this is because the geogrid at the top 1 and 2 are not providing enough reinforcement to the soil because the normal load above is less, but the geogrid below are actually providing. That's why the net factor of safety has decreased. So this is just a preliminary analysis that if you want to find out what is the factor of safety after reinforcing the soil. And sorry, if anybody has any questions. Okay, so I request you everyone to please mute their mic during the lectures. If you have any question, you can always raise your hand or ask in between, but just requesting everyone to mute the mic while the lecture is going on. So I will also just show you another case. Suppose if you can see that this is based on a limit equilibrium method. So here we are not getting any deformations. What are the deformations? We are just getting a value of factor of safety. Suppose you want to find out the deformations. So you probably use a finite element method. So Plexus is one of the most popular geotechnical software for finite element analysis. So I have just created a very basic simulation uh, for a reinforced earth wall. So here you can see that I have uh, done the construction sequence. So if you have to create a wall, you'll create one layer and then embed a geogrid in between, and then another. So I've actually created a construction sequence. So if you uh, calculate, analyze this, I will just show you an animation which I have done using the same construction sequence. So just try to look at the deformation of the soil. and how the tensile action of the geogrid comes into action. So you can see the, I'll just, you can see the deformation at later stages. It's deforming like this. So if this reinforcement would not have been there, this would have probably been failed. So this is the just a few applications. We'll come back to these problems again once the reinforcement part is discussed, and how the combined action of bearing and friction actually helps in reinforcing the soil. But just, and then we'll also discuss how we have to provide the parameters for these problems, uh, which are representative of the field phenomena. So I think now I'll just share the questions that we have, and I'll also upload this on the Teams channel. Okay, just hold on. Okay, so I think unfortunately there is some issue with Teams and I'm unable to upload any file. Uh, I think there is some issue with the IIT Delhi Microsoft account. It is not allowing, but nevertheless, I'll just share the screen so that meanwhile I'll try to sort out this. So you can try to solve these questions. After that, I'll scroll down for each of the questions, and then we'll at the end of like 20-25 minutes, we'll I'll show you the answers. If anyone has any doubt till now about the format of the sessions, or anything we have discussed so far, or any doubt in the lectures, they are feel free to ask. In case any doubt comes up, feel free to ask. So I've also shared the Google Drive. I think it's not the chat file is not working. So I've also shared the Google Drive link where all the questions will be there. Solutions are also there. So I suggest you not look at the solutions right now. We'll discuss it at the end. And this link will also be this week. And you can also save this and bookmark this link so that all the week problem solving sessions, uh, questions and answers will be uploaded here. So for your future reference. So if you have already solved these questions, uh, feel free to download the file and look at the other questions. I think there was an issue with my mic, so I'll just try to switch to. Hopefully now it's better. Uh, I've switched to a different network.
Yeah, Pranjal, now the voice is very good.
Okay. So I apologize. I didn't know that.
Yeah,
I
no,
think.
no problem. I just wanted to inform you so that you can
Yeah.
use.
Thank you. Thank you. Thank you, sir. Yeah. Sure.
I'm
Thank you.
here, but in case of any need, you can just call me. I'm here only.
Sure.
Hmm?
Sure. Sure. Thank you, sir.
Sure.
Thank you.
Thank you.
So I have just opened the link for everyone. Uh, yeah, so I have already shared the access. You're not the editors, you're the viewers. So please download the file. And then if you have to do edit anything, you can do that. But you don't have current access to edit the files, only you can just have a look at them. So you can check again, Mr. Naveen Kumar. The permissions have been changed now. So I've also shared one image in which what are the functions that are to be performed by geosynthetics. These have already been discussed: separation, reinforcement, filtration, drainage, fluid barrier or protection, and what are the geosynthetics that are typically used. And so that's good information to have. So this is taken from the textbook Introduction to Geosynthetics by Professor S.K. Shukla. So this is snippet is from that book. So I think this is a bit good relevant information. So I've just shared so you can save it. So I think most of you would have been able to solve the questions. If anyone has any doubt, I can ask, or I'll just share the solutions. Solutions are also available on the shared Google Drive, but I'll just share it here also. So I hope, yes, you are able to see. So first question, pretty straightforward. The answer is GeoGrid, generally used for reinforcement purposes. Second is about the manufacturing of geosynthetics. We know that most of the polymers we get from crude petroleum oils. The process has been discussed in the lecture. Then the most famous are PP and PET. Most of the geosynthetics are made from these two materials only. Which of the following geosynthetics is a geocomposite? It's a geosynthetic clay liner, which is widely used as a liner below landfills in place of natural liners such as clay. And then we have to define what this definition for a function means. So this is filtration, in which the migration of the soil particles are limited, but you allow fluid flow, which is across its plane. So, and then this is the exact thing that we had discussed in the finite element problem and the limit equilibrium problem. And this effect is called a membrane effect. And by I've told you, once the soil body moves, it stretches like a membrane and provides support to the soil. Then in geosynthetics engineering, most of the functions are served by. Although I feel that there is no definite answer to this, but still, I have shared that snippet. That's why I shared this snippet, and it tells you that most of the functions are can be actually provided by geotextiles and geocomposites. So you can just have a look at that table that I've uploaded, And you can see that GTX and GCP are the most common amongst all the functions. So which of the geosynthetics can serve the protection function? Geotextile. This has had also been explained using a case study in the lecture. Specific gravity, very descriptive question. Melting temperature, again descriptive, which has the highest model of elasticity. This is a very relevant property if you want to find out the deformations of reinforced soil structure. Then it's simple unitary mathematics that you have to find out what is the roll width. This is the solution given, and the answer is 4.5 meters. And then very again a very simple question in which we have to find out that the design strength is 60 kilonewton per meter. Uh, Not the design strength, but the design load is yeah, and the load is uh, design load is 60 and the strength is 80. So you have to divide it uh, so that we get a factor of 50. But it is to be noted that this is the factor of safety only against tensile failure. This is not the overall factor of safety. As I've already told you, in case of geotextiles, reinforced soil structure, or geogrids, uh, either the soil breaks, either the geotextile breaks due to tensile failure, or the geosynthetic might slip out because of there is not enough friction between the soil and the geosynthetics. So you have to see which factor of safety is minimum, and that is always the governing criteria. So in the questions that we had seen, the problem that we had just discussed, some portion was actually governed by the tensile part, and some portion was actually governed by the what we can call as bond between the soil and the uh, geosynthetic. So these are all the answers. All the this both these files have been uploaded. The lectures will also be uploaded. If you have any questions regarding this. So in the first 2 weeks, I think we'll have very simple questions, but later on as we go on, when numericals, more and more numericals are involved, I think we'll have more challenging questions and more numerical based questions. But in any case, if you have any questions, you can ask right now. So I don't think so there are any questions. So Professor Rajagopal, if you would like to say anything.
Yeah, actually, I don't have much to say, but I'm not sure how many students are there. Like only Naveen Kumar, Anupama, Sudarshan, Afrin, Diksha. Only five students. Yeah, Maunika, okay, Santosh is and this St. Peter staff. Okay, only some four or five students have joined. Um, yeah, out of about 450 people who are enrolled. Uh,
Yes,
yeah, I think
yes,
the
sir.
attendance could be better because for all the efforts that you are taking, um, yeah, but anyway, we'll ask NPTEL to office to alert the students to attend.
I think
Um,
in the Google group also, discussion group also, sir, I think we can if
yeah,
just drop a
yeah,
message that.
sure. I will definitely message that attendance could be better, especially from next week because the intensity of the course is going to increase. The first 10 days is only descriptive type lectures were held, and
Yes, sir.
Anyway, I will remind and thank you very much. I think you have taken good effort, and
Thank
I
you.
hope the students uh, mm, have understood the topics. Do you have any questions directly to me? So, okay, it looks like they have no questions. Yeah, I think maybe we can log off,
Okay, sir.
and I will send a message to all the students to attend more frequently. Hmm?
Yes,
Okay,
sir.
thank you very
Okay.
much. Thank
Thank you.
you.
Thank you, everyone. Thank you.
Okay. Thank you all the students who have attended. So look forward to meeting you more often. Okay, thank you. Bye bye.
Bye. Bye, everyone.